Welcome to the Deep Dive. Our mission, as always, is to cut through the noise and get you the key insights from sources you really need to know about. Today, we're diving into the future of sound, specifically AI music generation. We're looking at a pretty monumental new open foundation model called YuE that translates roughly to joy or music in Chinese.
Yeah, this feels like a big moment, especially for open source AI. YuE comes from HKU's T and MEP, and it's built on Llama 2, which is already powerful. But the key thing here, it's not just making, 15-second jingles. It's designed specifically to crack that really hard problem, the lyrics to song problem. We're talking full songs, coherent, up to 5 minutes long.
Right, 5 minutes. That's the core challenge we're going to unpack. How does this open model manage to compete with, or even sometimes beat, the big proprietary names like Suno and Udio? But maybe first, let's just set the stage a bit. Why is turning lyrics into a full song? Why is this so incredibly hard for AI?
It really boils down to three main difficulties that AI traditionally struggles with. First, there's time and structure. People call it the long-range dependency problem. Real songs have structure, right? Intro, verse, chorus. Making an AI maintain that musical idea, that emotional arc, over 5 minutes without, forgetting what it started doing, that's incredibly tough.
So they kind of lose focus, start strong, then drift off.
Exactly. Then the second challenge is signal complexity. Music is usually polyphonic, lots of things happening at once. Vocals, drums, guitars. The AI has to perfectly coordinate all these layers, beat by beat. It's complex. And third, there's linguistic distortion. When people sing, it's not just talking on pitch. Singing changes how words sound, the phones, the rhythm. It's very different from speech. Aligning lyrics to that sung melody. Very tricky. You had to rethink things fundamentally for all three.
Okay, let's get into their first big idea then. Tackling that complexity, the vocals versus instruments problem, normally AI models try to use, a single token for everything happening in that split second of audio, but your sources say that causes problems.
It really does.
Yeah.
They actually coined a term for it. Linguistic information loss after tokenization, or LLAT. Basically, if you're using standard next token prediction and the backing music is really dense or loud, think like heavy metal guitars or intense drumming, that instrumental sound can just overwhelm the information about the words within that single token representation.
Hold on, so the music itself, like the drum beat, was literally making it harder for the AI to understand the lyrics it was supposed to sing.
That's exactly what their data showed, yeah. They measured it using word error rate, WERR. And in those dense musical sections, especially metal, the JUR just shot way up compared to when they tested with only the vocal track. The AI couldn't reliably follow the lyrics because the accompaniment was essentially masking the vocal data.
That's a really crucial insight. The AI needs explicit help to focus on the voice. So YuE's fix was this track decoupled next token prediction, right? Dual NTP, stop blending everything together.
Correct. That's the core architectural shift. Dual NTP builds in this idea of source separation from the start. So instead of just one token representing that moment in time, it predicts two separate tokens simultaneously. One for the vocals and one for the accompaniment.
But splitting the stream like that, wouldn't that make training much harder, more computationally expensive? What's the benefit?
It is more complex, yes, but the payoff seems to be worth it. It allows for more focused learning. The numbers showed dual NTP actually converged better during training. They reported about 0.4 lower training loss compared to the standard approach. But what that really means is it learns faster, more reliably, and crucially, it sticks to the lyrics much better. Even in really busy genres like metal, the model keeps track of the words because it has that dedicated vocal prediction stream.
Okay, so step one, solve the complexity, make sure the AI hears the lyrics. Now, that second huge problem you mentioned, time, keeping it coherent for minutes, not seconds. You said just making the context window bigger, like up to 6,000 tokens, didn't really cut it. The model still lost its way.
Right, brute force scaling wasn't enough. And this is where they introduce something really quite clever. They call it structural progressive conditioning, or COT. It's kind of a nod to chain of thought prompting in language models. Instead of forcing the AI to remember the entire song history from the beginning, they gave it, a structural map.
Like giving it the song's basic outline, intro, verse, chorus.
Pretty much, yes. They leverage that natural structure. You automatically breaks the song into segments. The paper mentions an average of about 13 segments per song. Then, during training, they feed the model this interleaved sequence. A structure label, like chorus 1 or verse 2, the lyrics for just that segment, and then the audio tokens for that segment.
Ah, I see. So the model only needs to worry about staying consistent within the current verse or the current chorus. It doesn't have to constantly look back 3 minutes to the intro.
Exactly. It conditions its predictions progressively, section by section. And this neatly sidesteps that problem, where positional information decays over long sequences. Standard models tend to lose lyrical control after maybe a couple of minutes, but QT helps maintain that structural integrity right to the end.
That makes a lot of sense for structure. Which brings us neatly to controllability. It's not enough to just generate a song. Users want to steer it, right? How does YuE handle things like voice cloning or maybe changing styles using its in-context learning setup, and how do they avoid it just copying the reference track?
Yeah, that copying risks what they call shortcut learning is a major headache when you apply typical in-context learning, or ICL, from speech directly to music. If you just feed the model a reference audio clip during all of training, it often learns the easiest thing. Just mimic that reference audio style and content. That's obviously bad for creativity and potentially raises copyright issues too.
Right. It becomes a parrot, not a creator. So what was their workaround for that entanglement?
They used a very specific delayed activation strategy for the ICL. The reference audio, usually a 20 to 40-second clip you provide for conditioning, is only introduced right at the very end of the pre-training process. They call this the annealing phase. And crucially, it only makes up about 2% of the total training time.
Only 2%. Wow. So they forced the model to learn general music principles first for 98% of the time, and only then teach it how to apply a specific style from a reference.
Precisely. By holding back that ICL data until the end, they stop the model from just latching on to the reference as a crutch during its main learning phase.
Yeah.
And the result is much more flexible and disentangled control over style.
The paper had a really striking example of this, didn't it? Highlighting the disentanglement.
Oh yeah, it's quite remarkable. They showed they could take, say, a Japanese city pop track with a female singer as the reference, just to set the genre and feel. But then they could provide completely new English lyrics, specify they want a male rap vocal. And YuE would generate that English male rap song, but keep the original city pop instrumental backing and overall genre feel from the reference track. That's really fine-grained control.
That's not just style transfer, that's like surgical music recombination.
Oh.
Okay, so we've got dual NTP for vocal clarity, SUIT for long song structure, and this delayed ICL for controllable style. So the big question, how did YuE actually stack up against the established players? Suno V4, Udio, Halu, Tiangong. What did the human listeners say?
Well, the evaluation showed it's definitely competitive. In terms of overall preference and how musical it sounded, YuE is right up there with models like Udio and Tiangong. It also clearly outperformed Hilo. Now, it's fair to say it didn't quite beat Suno V4 overall. Suno still seems to have an edge in maybe general polish or perceived quality according to human listeners.
But you got some clear wins in specific areas, didn't it? Areas linked to its design.
Absolutely. And those wins really validate their approach. YuE came out top, or very near the top, in music structure and arrangement clarity. That really speaks to the success of the Kata T framework. It also ranked highest among the open models for genre adherence and consistency between instruments and vocals. So it did what you asked it to do, structurally and stylistically. And its vocal agility was impressive too, achieving a median vocal range around 27 semitones, which puts it right alongside the best proprietary systems in terms of expressiveness.
And we shouldn't forget the impact of just raw size. The difference between their smaller and larger models was pretty stark based on the evaluations.
Oh, massively so. The human tests clearly show that going from the 0.5 billion parameter model up to the 7 billion one brought huge, unambiguous gains, both in just how good the music sounded overall and critically in how well it followed the lyrics. Scale really unlocked a higher level of capability here.
Which leads us to maybe the most intriguing part, those moments where scale unlocks things the researchers didn't even explicitly train for. These emergent abilities. This is where it starts to feel less like engineering and more like, well, something creative is happening.
It really is fascinating. It's like the AI started spontaneously discovering music history and technique. Beyond just singing the notes, the larger model started exhibiting complex vocal techniques all on its own. Things like vibrato, smooth slides between notes, glissando, even bel canto operatic styles. And at the other extreme, convincing death growls for metal tracks, and even niche things like traditional chambé folk singing techniques.
So you ask for opera, you might get something genuinely operatic. Ask for metal, get a proper growl without specific fine-tuning for each. That's why.
And it wasn't just vocals. It started making intelligent compositional choices, too. Like if you gave it jazz lyrics and they ran out, the model might just start scat singing appropriately. Or for a cappella prompts, It would generate complex multi-part harmonies automatically. It even showed context awareness, like adding a fitting harmonica solo during a natural pause in a folk song's lyrics.
And those cross-cultural examples you mentioned, they really drive home that it's not just mimicking, it seems to have some kind of deeper understanding.
Exactly. The ability to blend genres in sophisticated ways, like that example of creating Chinese gangster rap, but using traditional Japanese shamisen sounds and scales for the backing, that suggests more than just pattern matching. It implies some understanding of the distinct elements of both musical traditions and how they might be fused together creatively.
It definitely cements YuE's place as a landmark achievement. The first really capable open source model for generating full, controllable songs from lyrics, genuinely challenging the commercial systems. It tackled those big three problems: time, complexity, and vocal distortion.
And what's really thought-provoking, I think, is how creation and understanding seem linked here. You is primarily a generative model designed to make music. But the research also shows it's surprisingly good at understanding music. Specifically, it achieves state-of-the-art results on a music understanding benchmark task, recognizing the musical key of a song, GS key recognition on Marble, hitting 67% accuracy. So it doesn't just create, it seems to have developed a pretty sophisticated internal grasp of fundamental musical concepts like tonality.
That really does leave us with a fascinating question to think about, doesn't it? If a model that excels at creating complex, structured music is also one of the best at recognizing core musical features like key, does that mean true AI creativity fundamentally requires, or perhaps even arises from, a deep, learned understanding of the domain itself? Is creation simply the flip side of analysis, something to ponder until our next deep dive?